And Behzad Fatahi is an associate professor of Geotechnical and Earthquake Engineering at the University of Technology, Sydney. He joins us there live. I have been wanting to talk to you for days. Unfortunately, last time we had a bit of a bad signal. But my first question is, can you even earthquake-proof a building up to a 7.7, 7.8 quake? Or at that point, are all bets off?
Yeah, yes, the short answer, yes, Michelle, we can do that. So we have got a great experiences around the world that many buildings, different structures, bridges, and so on, they stand larger quakes. And the point there is that we have to use the new technologies, recent advances in the new materials, new technologies, using updated design codes, make sure the construction practices are up to a good standard, the designs comply with the latest standards. Certainly we can. And we have developed, even at our university in Sydney, the new technologies that we can really reduce the impact of the earthquakes to the structures by just doing something cost effective in the foundation, actually.
What's the latest method? What's the newest technology in earthquake-proofing buildings?
People, they have been working on different fronts, actually, to establish different materials that they can use for the buildings. For example, some of the advancements that has happened in the structural field is using more advanced and even more cost-effective base isolation techniques. The other fronts related to foundations, researchers, including our team and others around the world, they have been working on different types of foundations that they basically can absorb the energy of the earthquake in a way it won't pass it to the structure. So by modifying the characteristics of the foundation, they could do it. So these are the techniques basically we are recently around the world, people, they have been working.
Yeah, it's a really interesting area of study. And one question that people have when they look at these scenes of disaster, you'll see one building flattened, and then the one right next door that is essentially the same building. It may have even been built by the same company. Sometimes in a complex, there are multiple buildings that are the same. That one will be standing. What does that tell us? Is it the building itself, or does it have much to do with how the energy traveled through that ground?
There would be multiple factors and reasons for such incidents. For example, one issue can be related to the changes and differences basically in the ground condition. Like there is no guarantee that if two buildings are exactly the same, and they are, let's say, 50 meters, even you say less than that, 20, 30 meters apart, they have got the same ground condition. So one might be sitting on a stronger ground, that deposit was different. One might be sitting on a softer material that may be soft clay or liquefiable material. Maybe some of the construction practices in one of the buildings was not done properly. So there would be a variety of reasons, and it's not very surprising. But if it's related to the ground condition, so it is likely that, for example, when you have got grounds which are soft, the earthquake is quite well known after Mexico City earthquake, that earthquake can basically amplify through the softer grounds, that therefore it can, even if the building is stronger, but then the building receives a much stronger earthquake hit.
All right, Behzad Fatahi, excellent to talk to you. Thanks for your expertise.